It's Miss Aguilar. I'm just going to go over the lab that you're going to be doing on Wednesday. So hopefully you guys are watching this on Tuesday night. This is your homework for Tuesday night. It's just going to give you guys a chance to see what you're supposed to do for the lab. Even though I'm not going to be there, the sub will still have instructions on what to do. But, it's just an extra helpful tool. Anyways, let's just get started. So this is the image that you see in the front of the classroom right now. It's set up for you guys. You have a long, well, not a long, but a short little track right here, and this is where the marble is going to roll from. You have a little sort of stand here or tower that has the track attached, and then you have two meter sticks here. If you only have one meter stick taped on the table, that's fine. I tape two just to kind of help show everybody a kind of guide on what you can do. If you only have 1 meter stick, that's fine. Anyways, what's going to happen is that you're going to drop a marble from here, and then you're going to let it come down, and then you're going to start timing it when it reaches this position here, and then stop the timer when it gets to the end. So let me just kind of give you a close-up look. So here is the image of the tower. A couple things that are going to be important is that you tape it down. So you can see here that I've shown it taped down. If you don't tape down the base, then it won't stand straight, and then it will be all wobbly. You want to make sure that the stand is not too tall. It's totally up to you, the height of this, but I think anything a little bit taller than this would be fine, but anything above that is going to be too much. And then what happens is that your marble gets going way too fast, and it's tough to time. I've marked here same spot because it's important to remember that when you are dropping your marble, you're going to drop it 10 times to time the velocity, and you always want to drop it from the exact same spot. Don't drop it anywhere below or beyond this little red clip. You want to tape it like above the red clip or drop it above the red clip, but anything below, it won't be very accurate. So you're going to drop your marble from here or release it from this spot, and then you're going to let it travel down the ramp. Now, when it gets to the end of this green ramp, you can see I've marked start timer here. This is going to be where you start the timer. As soon as the marble hits the table or comes to this 1 meter mark or this 0 mark, you're going to start your timer, because what you want to do is time how long it takes to go from the start to the stop. So this is going to be this is 1 meters of distance. So you're just trying to find an average velocity as it's rolling on the table, not on the ramp. The ramp just gives it the starting kind of speed or whatever you want to call it. This is the end of the 1 meter. So you're going to stop the timer right when your marble gets to this spot here. A kind of helpful tool might be that somebody is standing at the edge of your desk waiting to catch the marble, because you don't want the marble to roll off the table for the start of this lab. All right? Okay, so let's look at the lab handout. So everybody in your group is going to get this lab handout, so 1 per person in each group. And you guys are going to start off on Wednesday just reading through it, but I'm going to give you some sort of tips. So the first part here is asking for the horizontal distance. This is x is equal to velocity in the x times t. This is going to be that magic value. This is going to be the value that you're going to use to calculate exactly where the marble is going to land on the ground. And then you have the time equation in the y direction. So your vertical distance time equation is here. And the third little bullet point here is asking, what do we already know about the marble drop problem? Well, we did this example last Thursday on the back of that projectile motion handout. So hopefully everybody has it, because I didn't collect it. So hopefully you guys have it with you on Wednesday to kind of take a look at how you did the calculations from the sample problem. It says draw a picture to help. This picture is something I tried to do here. It's kind of, wonky, but whatever. The blue part right here is just an image of the table. This is an image of the ramp. And then this 1 meter mark is just kind of an image of the distance it's going to travel as you're timing it. The delta y is the height of the table. The delta x is how far out from the table will the marble land. So your mission is to accurately predict to the centimeter the exact location of where the marble will hit the floor. Where the marble will hit the floor is your delta x. Killing the cricket as it rolls off the edge of the table. So killing the cricket just means that it's going to land on the exact spot where you set it up. You're going to be really accurate when you're doing your measurements, and you need to make sure that you guys are just paying close attention to the details. So to start off, you're going to set up the ramp. The ramps are going to be set up for everybody. So if you're in period 1, you guys are going to be setting up the ramps for all the other classes, and then they're going to stay set up until Thursday. And on Thursday, 7th period classes are going to take them down. I want to make sure you guys remember to use the same marble each time you're trying it, and then try to maybe mark your marble or put it to the side, because when you actually let it go for the final time, you want to make sure you use the same marble. I know it seems like it would be kind of obscure to use the same marble, but it's actually kind of important. All right, so you're going to calculate the average velocity of your marble by letting it roll off of the ramp, like I said before. So it will roll off the ramp, and at this point right here, you're going to start your timer. And then you're going to let it roll that 1 meter. And at the end of that 1 meter, right here, you're going to stop your timer and catch your marble before it hits the ground. And with those times, you're going to write them here in this time column. You're going to do this 10 times. You're going to let it roll that 10 times, okay? Each time dropping it from the same point on the ramp and timing it. The times are going to go here in this column. And then for each of these trials, you're going to calculate then the velocity. To calculate the velocity, it's going to be 1 meter over t, and the 1 meter just represents the distance it's traveling. Remember, that 1 meter is constant. It's not going to change because you're always going to time it from the start to the end of the ruler. So you're going to then end up with 10 different velocities. With these 10 velocities, you're going to calculate the average velocity. And we all know how to do average, right? So you'll calculate or add up all these velocities, trial 1 through 10, divide it by 10, and that will be your average velocity. The average velocity you're going to use then in this equation up here to calculate how far from the table your marble will land. Step 4 says that you're going to measure the edge of your table. So what you want to do is you want to use a meter stick to do this, and you want to make sure that the 0 end of the meter stick is on the ground. You're going to put it flush up against the table, so then you can just kind of eyeball where the edge of the table is marked on your ruler. And then this is going to be your delta y value. So with the delta y, you're then going to use this vertical time equation that you see right here, and you're going to calculate the time it's going to take for the marble to roll off the table and hit the ground. So you're going to use 2 and multiply it by your delta y, which you get from number 4, divided by g. And just so everybody knows, the g we're using today is going to be 9.8. We're not going to use 10. We're going to be really accurate. We're going to use 9.8 instead of 10. So with time calculated, that you're going to use, for number 6, the delta x equation, right? So delta x is equal to velocity in the x. The velocity in the x is going to be from your average velocity times time, which is going to be the time you get here in number 5. And that value then is going to be where you're expecting your marble to fall or land on the ground. So let's say that you calculate your delta x to be 1.2 meters, right? So what you're going to do then is you're going to take a whiteboard, and you're going to place a whiteboard on the ground, and then you're going to be given the Kricket score sheet. So the score sheet is 1 per group. You only need 1 score sheet. You're going to tape the score sheet to the whiteboard. And then there's going to be a little sort of centerpiece or a bullseye with a little cricket holding a sign that says "Kill Me." And you're going to tape it to the board. And that cricket is going to be the mark of where your exact delta x is. So again, if your delta x was like 1.2 meters, you want to make sure that the cricket is 1.2 meters away from the edge of your table on the ground. And so then you're going to make sure it's all nice and perfectly lined up. And then you're going to let the sub know that you're ready for him to watch you allow your marble to roll down the last time. Now, each time the marble rolls from the track while you're doing the trials, it's not going to hit the floor. It's only going to hit the floor 1 time, and that's once you've already calculated everything. So you're going to let the marble roll from the track the last time. Before you let it go the last time, you're going to put a piece of carbon paper down. So have the sub put a piece of carbon paper down on top of your score sheet, your Kricket score sheet. Then you're going to let the marble roll down. The carbon paper is there to mark where your marble lands. The marble will land on the carbon sheet, which is on top of the score sheet, and it will make a mark. And then you'll circle it. The sub will initial it. And then what you're going to do is you're going to take that score sheet off of the whiteboard, staple it with everybody's lab sheet. So if you're a group of 4, there will be 4 lab sheets, this sheet here, and then 1 score sheet, and you're going to turn that in. And then when I get back, I'll score them and grade them for you guys. Once you're done letting it roll down the last time, you're going to do the analysis part, which you see here. You're going to, talk about what your predicted distance is. Now, your predicted distance is what you calculated in number 6. And number 2 is what was it actually. You could leave your paper where it was and then just make an actual measurement. And then just finish up with the last of those questions. All right, you guys, hopefully this was helpful for you. If you have any questions, just ask the sub. And I hope you guys have a great week. And I'll see you on the 10th.